Hi. Many students ask me how do I memorize the electrolysis setup when there are just so many configurations and so many different type of questions and they can't understand a single thing. First of all, I would like to say there are essentially only 4 types of configuration that will require close attention: molten, dilute, concentrated electrolyte, and active electrode. But also simple cell, but that's simple as the name suggests. Next, there are various memory techniques, but the one I use and find most effective with regards to this chapter is the forming of a visual. Draw the setup of the 4 configurations I mentioned earlier by only taking quick reference of the textbook diagram. Understand it and draw them based on your own understanding. Do not just copy, and this will not allow you to register the information as quickly as drawing it by yourself. After drawing them several times, and as you perfect the drawing to your style, you probably already form a mental image of the diagram in your head and you can recall them whenever you need to. So today I'm going to go through 2 electrolysis questions and hopefully they will help you understand this chapter better. Alright, here I've chosen a question from O-Level Pure Chemistry 2015, Paper 2, question A5. Let us first have a look at the question. Dilute aqueous sodium chloride forms hydrogen and oxygen during electrolysis. So I've gotten the diagram printed here. Alright, for part A, write ionic equations for the reactions at the cathode and at the anode. So at the cathode, we can see that hydrogen is being produced. Okay, so for part A, at the cathode, hydrogen comes from the hydrogen ions reacting with the electrons, giving us our hydrogen gas. Okay, so this is aqueous, and when we balance this, we'll need 2 of the hydrogen ion and 2 electrons. Okay, so for the anode, we see that the oxygen is being produced. Alright, at the anode, oxygen comes from the hydroxide ions. So AQ, that gives us our oxygen. And because we've got a hydrogen, so water is still being produced and electrons. So when we balance this, we'll need 2 of these, and that will make 4 of these, and this will give us 4 electrons. Alright, so this hydrogen is liquid and oxygen is given off as gas. Alright, so this is for part A. Okay, let's look at part B. The gases are collected and their volumes are measured. In theory, the ratio of hydrogen to oxygen should be 2:1. Okay, so we'll jump to part 1 first. Why is the theoretical ratio of hydrogen to oxygen 2:1? Okay, so B part 1. Okay, so let's look at these 2 equations considering that the overall equation is, here we have got the water reacting to give us hydrogen gas and oxygen gas. Okay, so to balance this, we'll need 2 and 2. Alright, so as the mole ratio of the gases is 2:1. The volume ratio is 2:1. Alright, so that will be for B part 1. So back to the question. Oxygen is more soluble than hydrogen in water. This changes the ratio of the gases that are collected. So for part 2, they're asking, explain how and why the solubility of oxygen can affect the ratio of hydrogen to oxygen that is being collected. Okay, so as oxygen is as some oxygen. Okay, let's try and change this a little bit. As some oxygen is dissolved in the solution. Okay, less oxygen is collected as gas, so the ratio is, the word is affected, right? So the ratio is greater. Okay, there we go. So this is the answer for part 2. Okay, so for part 3, the difference from the expected ratio is greater when the electrolysis starts, but less noticeable after the electrolysis has been running for some time. Suggest why this happens. Okay, so this has got to do with the solution. As the solution gets saturated with dissolved oxygen, okay, less oxygen is dissolved and is collected as gas. Okay, so when they are collected as gas, then the difference to the theoretical ratio is not that great anymore. Alright, so let's look at part C now. What happens to the concentration of sodium chloride during the electrolysis? Explain your reasoning. Okay, so this one is because we have a water decomposing. So this is part C. As water is decomposed to oxygen and hydrogen, there will be lesser water and therefore the concentration of NaCl will increase. Okay, so lesser water, more NaCl present per unit volume, therefore the concentration will increase. Alright, so now let's look at part D. The same apparatus can be used to electrolyze concentrated aqueous sodium chloride and give one similarity and one difference between the products of the electrolysis of dilute and concentrated aqueous sodium chloride. Okay, so if we look at the similarity first, okay, similarity wise, both will give hydrogen at the cathode. Okay, so at the cathode, right, if we consider the two cations that are present, which is the hydrogen and the sodium, alright, the ease of discharge for hydrogen ions will be a lot higher. Therefore, for both of them, hydrogen will be collected. Okay, but for anode will be a little different. Okay, so at the anode, okay, dilute NaCl will produce oxygen and water, while concentrated NaCl will produce chlorine. Okay. So when we compare the anion that's present, we have got both the hydroxide anion and the chloride anion. Okay, so when for the dilute one, right, the amount of the ease of discharge for the hydroxide ions will be a lot higher. So we get both the oxygen and water. While for the concentrated one, the ease of discharge of chlorine will be higher. So we get the chlorine gas being produced. Alright, so for part E, platinum metal electrodes are used. Why is platinum a suitable material for use as an electrode? Alright, so for E, we have platinum is inert and will not react with the electrolyte and product. Alright, so here we want the electrode to not interfere with our electrolysis. Therefore, as platinum is inert, it will be a suitable material. And so this is the answer for this question. Alright, so here I've chosen another question from O-Level Pure Chemistry 2014, Paper 2, Question A5. So first, let's have a look at the question. A student investigates the amount of copper that forms on the negative electrode during the electrolysis of aqueous copper to sulfate. The student uses this apparatus, and I've copied down the diagram here on the board. Basically, it's using both the carbon electrode and copper to sulfate as the electrolyte. Alright, so for part A, write equations for the reactions that happen at each electrode during the electrolysis. Include state symbol. Okay, so if we consider the positive electrode, okay, then we'll have to consider the negative ions that approach it. So we have both the hydroxide and the sulfate ions, and hydroxide ions will have the higher ease of discharge. So at the positive electrode, we have the hydroxide ions becoming oxygen, and because of the hydrogen it forms water as well, and it gives off electrons. So in order to balance this, we need 2 here and a 4 here, giving off us 4 electrons, including the state symbol, the hydroxide coming from the aqueous, oxygen is a gas, and the liquid water will come off as liquid. Okay, so if we consider now the negative electrode, we'll have the positive ion, which is the hydrogen ion and the copper ion. And so the copper ion will have a higher ease of discharge. So let's write here the negative electrode giving the copper 2 plus reacting with electrons, giving us the copper. This is the solid. And then this is the aqueous, 2, so we need 2 electrons here. Alright, there you go. So this is for part A. Let's look at part B now. The student measures the mass of the negative electrodes at the start. He allows the electrolysis to continue for 10 minutes. He dries the electrode, reweighs it, and then replaces the electrode to allow the electrolysis to continue for a further 10 minutes. He repeats this process until the mass of electrode does not change. The table shows his results. So I've copied down the table right here. So for part 1, what general pattern is shown by the result? Okay, let's have a look. So we can see here as the time progresses, the mass of the electrode also increase. Alright, so we can say that the mass of electrode increases as time progresses. Okay, let's have a look at part 2. The student makes an error in recording one of the mass reading. Which result is most likely to be an error? Explain your reasoning. So let's look at the trend of the mass of electrode. From here we can see that it increased by 0.4 gram. Here is about 0.24, here is a little more, and subsequently it's all 0.4 gram. So probably the 20th minute has got some error there. Alright, so the mass recorded at the 20th minute seems to be the error. Alright, so they need us to explain the reasoning. Okay, as the mass of electrode increase by only 0.24 grams at the 20th minute, while it increases by 0.4 grams for each 10 minutes recording, for each 10-minute period. Alright, so this for part 2. Let's look at part 3. Suggest why the mass does not change after 60 minutes. Alright, so after 60 minutes we see that it doesn't increase anymore. Okay, this is so as after 60 minutes all the copper ions in the electrolyte have been discharged. Okay, so if all the copper ions has already been discharged, there's no more, and so it wouldn't increase anymore, right? So for the next part, part C, the student repeats the experiment. This time he uses copper electrodes. So how would you expect his result for the experiment to differ from his first experiment? Explain your reading. Alright, so now he's using an active electrode, the copper electrode, alright? So firstly, the mass of the electrode will increase after 60 minutes. So this is part C. Will increase after 60 minutes. Okay, firstly the copper anode will dissolve to give more copper ions in the electrolyte. To give more copper ions in the electrolyte. So after 60 minutes, there are still copper ions available to discharge at the negative, the cathode. Alright, so this is the answer for part C. Because as the copper electrode is an active electrode, it will participate and it will dissolve to release more copper ions into the electrolyte. So now as the number of copper ions in the electrolyte increases, after 16 minutes there will be still more, and then it will continue to be discharged in the negative electrode. So it will continue to see a mass increase. Alright, so this is the answer for the whole question.